What is the length of the red line? Line construction, Pythagoras' theorem, arithmetic and algebraic operations are used to solve this question. Label points A, B, C, D, W and T. Let O and G be the centers of semicircle of radius, R, and yellow similar circles of radius, 1 unit, respectively. Line BC equals line AD. That is equals to line CD, which equals to line AB. It is because opposite side lengths of a rectangle are equal. Also, line OD equals R, the radius of the semicircle. Join line OD, line BC, line AB and line OB, respectively. This implies that line OA equals line OD minus line AD, which equals to R minus 1. And line OC equals large R plus small r, which equals to large R plus 1. Consider triangle DOC. By Pythagoras' theorem, the square of line AB equals the sum of the square of line OC minus the square of line OD, which equals to 4 times R. This implies that the square of line AB equals 4 times R. Take the square root of the equation. We have that the length of line AB equals the square root of 4 times R, which equals to 2 times the square root of R. Since line AB equals line WT, which equals to line CD, it follows that line WT equals 2 times the square root of R, that is equals to line CD. We call it equation 1. Hence, line OT equals line WT minus line OW, which equals to 2 times the square root of R minus R. It signifies that line OT equals 2 times the square root of R minus R. Join line GT, which equals to small r equals 1. Label point E. This implies that line OG equals line OE minus line EG, which equals to R minus small r. That is equals to R minus 1. From right triangle TOG. By Pythagoras' theorem, the square of line OG equals the sum of the square of line GT and the square of line OT. Substitute values. We have that the square of R minus 1 equals the sum of square 1 and the square of 2 times the square root of R minus R. Expand brackets. So that the square of R minus 2 times R plus 1 equals 1 plus 4 times R minus 4 times R times the square of R plus the square of R. Cancel equal but opposite terms. This implies that 4 times R times the square root of R equals the sum of 4 times R and 3 times R, which equals to 6 times R. Hence, the square root of R equals 6 divided by 4, which equals 3 divided by 2. We call it equation 2. From equation 1, line CD equals 2 times the square root of R. Substitute equation 2 into equation 1. It follows that line CD equals 2 times half of 3, which equals to 3 units. Since line CD equals the length of the red line, therefore, the length of the red line equals 3 units.